right, welcome everybody. This is NSGIC's EDH for 3D forum, and which is a monthly occurrence we've been having here with the last few months focusing on education of previous projects and standards going forward. So we hope in these next few sessions to give everyone a really good background to what EDH for 3D NHD really means and what we're trying to accomplish. So welcome everybody. Please note the presentation is being recorded, and for attendance purposes, if you would please enter your full name and organization in the chat. That way we don't have to decode your Zoom name to figure out who you might be. Also, during the session, please put any questions that you might have in the chat, and we will review them and get to them at the end of the presentation. As many of you guys already know, EDH for 3D NHD is a cooperative agreement between NSGIC and the USGS, and the main intent is to engage states and local governments and private sector partners in this conversation to explore options of deriving high resolution hydrography data using 3D LiDAR. And if you're in Alaska, it's IFSAR. So, and there we go, slides. Oh, that's what I just said. How about that? You already knew that. Okay, moving on. Oh, I should mention this. This week or month we're focusing on New Jersey's EDH activities. I'm going to give a brief project update here first, though, before we get into this. Like I said already, a lot of what we're doing now are monthly forums, and all this information is being saved on the learning link, and also encourage all of you to engage through our My NSGIC community. We have an interest group, and we have a working group that will evolve as we get more deeply into this with states who are more actively involved in the process of developing elevation-derived hydrography. But the work or the interest group is open to everyone, and we encourage anyone interested in it to please participate. We currently have a experience inventory active, a survey 123. I will post the link into the chat here in a moment. And it's also posted on the My NSGIC page under one of the posts. But what we're trying to do here is establish a baseline and an understanding of state and regional EDH activities that have already gone on in the past or maybe going on currently. And I already warn you, if you put something in, we might ask you to present on it. So. And conversely, if you're presenting on it, we will also ask you to eventually fill out the inventory, because this survey 123 is going to then feed a story map and a dashboard that we're developing to share this information through our information hub that we're currently under development. Okay, so today's presentation is the New Jersey elevation-derived hydrography activities. We're happy to have Andy Rowan, our Deputy Chief Technology Officer from New Jersey, and Craig Curtis. How do we say that, Craig?
Koutros.
Koutros, I'm sorry.
Koutros, yeah.
Koutros, yes. Craig Koutros, the database manager and GIS specialist from the New Jersey Department of Environmental Protection, the GIS Bureau. And so if Craig, I will stop sharing, and if you would share your slides, we'll let you take over.
Andy, did you want to say something?
Sure, I'll kick it off. So greetings, I'm Andy Rowan. I used to be the Deputy Chief Technology Officer for the state here. I didn't like that title, so I gave it back. And I'm back to being just the plain old Geographic Information Officer now. So I work in the IT agency, and Craig works in the Department of Environmental Protection. When I started in GIS in 1989, the Office of GIS in New Jersey didn't exist yet. And DEP at that time was really the lead agency in state government in adopting GIS technology. This was long before I worked in state government, but back then in 1989, Craig was one of those people at the DEP. He's been doing GIS there since 1987. And among the things that he's done there is the statewide land use land cover mapping, which happens every 5 years or so for the last, 35 years, Craig. And also hydrography, and now elevation-derived hydrography. So I will hand over to Craig. Craig, as Phil said, Craig is a GIS specialist at the New Jersey DEP and is the lead on the hydro activities there. Craig, take it away.
Okay, thank you, Andy.
Looks good.
Okay. All right. What I'd like to do today is give you, an overview of the projects that we get involved in and how I've been able to incorporate the hydrography data into some of our other data and leverage the elevation data. So I'm going to give you a background of the core data layers that we need and produce here in the Bureau. Again, I'm a GIS specialist with the Bureau of GIS for the New Jersey Department of Environmental Protection. So just an overview of my background. I spent 20 years with the department in the Forest Service, so my background is in forestry. And the department was getting into mapping at that time in '87. I jumped in and was trained with ArcInfo and started all of the early forest data layers. 20 years after being with forestry, I moved into the Bureau, and probably over the last 8 years, I've been taking over the enterprise GIS data manager responsibilities. So what that entails is taking all the data that DEP users produce and getting it into our enterprise database. And I also manage all of the editing workflows of all that data, maintenance, so versioning, checkouts, replications, etc. So everything that's been edited now through the enterprise gets pushed out to our applications or our open data page. And we have quite a bit of data, probably in the 400 to 500 feature class numbers. Just for level of work, we did 195 feature class updates in 2020, and we probably produced a little bit over 100 new feature classes that different groups needed. So I get involved in those project database developments, getting their data organized into a structure and then onto the enterprise, and then setting up all the replications for that data, and then managing any of the additional editing. And then I get involved in special projects that our group coordinates, specifically the land use update land use land cover updates that we have done over the years. I was involved with the early national hydrography data set update and our conflation work that went on in 2009. And I've been the NHD steward, and because I can't get anyone else to do it, I'm the WBD steward now also. So I don't do either of those roles responsibly. All right, so some of the projects I'm going to go over are our statewide imagery. We collect it roughly every 5 years. We have a 2020 overflight that's in final stages of QC. It hasn't been delivered yet, but we've also contracted with a company called Nearmap, and we paid a little extra to get full statewide spring collections over the next 3 years, and that is just under 3-inch resolution. It's not ortho-rectified, but it gives our field people good current imagery. I pretty much put together the Land Use 2015 update, and I'm going to go deeper into that. And we are preparing for a 2020 update. It usually takes about 1.5 years to complete. And we have proposals in. We're just waiting on the imagery to start that update. And I'm going to go over the LiDAR collections and the history of them, where we're at now, and what I've been doing to incorporate the national hydrography data. Again, in 2009, I spearheaded the conflation of our local hydrography into the high-res NHD. So we have quite a bit of imagery on our servers, and it's all available through a drop down to our internal users. So we do all of our mapping to the latest imagery. So the 15 was 1 foot resolution. And on the right side of the screen, we cover 13 Huck 8s, 275 Huck 12s, and we have 970 Huck 14s. So all of our mapping is done to this 1 foot resolution imagery. And any day now, again, we should be getting the 2020s in, and then we'll make that available on our servers. So when we get a new collection of imagery in, we have been trying to keep up with producing this land use update. And so I started with the 2002, and then have been involved in the 7, 12, and the 15 updates. And what we noticed after we got the land use updated, all of our hydrography, which was a separate layer at the time, was not, and it just needed a lot more massaging to get it back into NHD compliance. So what I did was, in the early land use layers, so for our land use, we have 86 land use codes, these 6 land use types. So anything that is water, I've added some of the key NHD attributes. So now all of this data is embedded into our water coding in our land use update. So we only carry 2 years in our land use updates, 15 and a 12. So the next one, we will only have the 2015, and then this will all be 2020 coding. And this update of codes for NHD will be representing the 2020 data layers. So if it's a water body in 2020, these codes will get carried over. If it changes to some other land use, these will be nulled out. So also within our NHD, because of some of our groups who need to know some of the areas they're in and some of the other coves and things like that, all of the splits for coves and thoroughfares and all that have been incorporated into this water body layer or land use layer. And that too also will get carried forward. So we have some unique codes such as bridge over water, which we found from the 2012 update that not only did we need to have splits in there for stream rivers from tidal bays, but this used to be coded a transportation road, but to meet the NHD need, we created this bridge over water, and it will carry the NHD coding. So it's a land use code, a bridge over water, but it also has the codes in there that we could simply dissolve on and bring this into a water body layer. So again, here you can see that we've carried over the names of the water bodies and splits of different water. All of this gets dissolved out through a conflation process, and it'll never make it into the national NHD. So what we do is we take all the water from the land use update and create a water body layer, and that's what you're looking at here. So all of these water body layers, if it's an artificial lake, it might have a reservoir code, an HD code, or a any kind of perennial water body, etc. Bays and estuaries are some of the codes. Dredge lagoons are also carried over. Okay, so if you look at the just the water bodies onto our imagery, we've ended up having to, because of imagery, have low tidal areas start to show up in the imagery. So we created a code of tidal mudflat, and those are essentially the low-lying areas that you see on some imagery. But they will take on the codes of the adjacent water body for NHD purposes. So we map our water bodies down to a quarter acre, and the stream rivers are 30-foot width. However, in many cases, it goes down to sometimes 10-foot in width. So what happens in these low tidal areas is it's visible on one year of imagery and not on the other. You'll see these low-lying areas in the hydroflattened dam. But in NHD, for NHD purposes, we're mapping to the high water lines or high tide, and again, to imagery. So we can only go based on the water that we're seeing on our imagery. And also any splits in the NHD flow line for artificial paths are done at that high tide interface between the land use upland areas versus the water. So if you take out just the water bodies, we have 39,744 records of coded water bodies. Again, looking at the water bodies, when you bring it in onto our hillshade, you will see some of these low-lying areas that we've coded tidal mudflats. They're in the LiDAR, they show up in the hillshade, so we kept them in there as a tidal mudflat, separate code. But again, this gets merged with the adjacent water body for NHD. You also notice that every stream in New Jersey takes on the labeling of the polygon that it's going through that has been split on each of the water bodies. And every stream coming off of that main channel is coded tributary. So you could tell where these things were coming from. And all the estuaries and Atlantic Ocean coastlines have been mapped. We have a lot of people that do water monitoring, marine fisheries group. They needed some of all this coding for their point collections and for licensing, etc. So if you look at just the water bodies on the left, again, 39,744 records. By the time you dissolve all that out for just NHD, that is what we'll use for any conflation work we're going to be doing. A lot of the names are in there, but unless they have an official GNS ID, they will not get loaded into the NHD nationally when we do the conflation. And we actually had all these named before we did the conflation in 2009, and that is when we found out that they get dropped. And if you look at all the flow lines, we have 268 821 records of flow lines that, again, have all this coding that you see in the center screen as far as NHD. And this schema has changed from the current NHD database schemas, but I've been carrying these over till we go through another conflation of all of this data. So now we're starting to look at the LiDAR collections that we have done in the past. So on the right side of the screen have been all the collections over the years that were made available to us, either through county collections or collections that our rep, Roger Barlow, helped us coordinate and get collected. On the left are the more recent ones that are all QL2. Two of them are in feet, two were in meters, different years. And so we serve these out internally to our users, and they're available through Andy's group for download and through the 3DHP LiDAR collection site. But what we do with them for our internal use is my coworker, John Tarowski, who might be on the call, takes the LiDAR collections and merges them, and we create a 10-foot DEM out of them. And that serves our group pretty well for relatively fast viewing and for our hillshade. A lot of the local counties take our data and also utilize that layer. But we do offer both on our either web page or internal applications. So we have customized drop downs in our Arc desktop and Arc Pro environments where we served out all the LiDAR collections, a DEM and a hillshade, and the ones with the red dots are the ones that were just utilized to produce the latest 10-foot DEM. I take the water bodies layer and the stream network, create the geometric network, and it's available to our users for tracing. We have a lot of groups that do water monitoring, drinking water intakes, and pollution spills, things like that. And they'll utilize the network tracing for determining areas that they either need to warn about pollution issues or notify an intake. That type of notifications go out, and we're the ones that utilize this internal geometric networks. So in addition to the individual LiDAR collections, we offer that statewide one again, which is the 10-foot DEM John produces. And we have an actual cut line that he produces. And so you can click on any portion of the DEM and determine which collection that particular area came from. So because of all those multiple LiDAR collections we had in the beginning, we needed a process. So we reached out to a vendor to develop. We were looking at updating our HUC 14s at the time to utilizing the elevation data. So we had a vendor produce this document, which is available on the Confluence on that link at the very bottom there. I still use this document. And John still uses the process that was developed for creating the 10-foot dam. So it goes step by step, screen by screen, with all the inputs that we flushed out, and still very valuable document. And this is pretty much the workflow that all the screens go through. So we take the raw LiDAR points, do all the things you would do to the DEM to get to the level for sub-basin delineation. But in there is also all the processing that we go through for the streams and drainage lines. So these were the areas that we had done. So New Jersey's has some, I call them mountains, but most of you probably don't call them mountains. Up in the Northwest, and then the coastal area is a lot of tidal area. On the Southeast, we have a lot of agricultural area, relatively flat, and the Northeast is urban. So you get quite a bit of diversity when you start to look at, the point clouds. A lot of buildings to remove in the north, and a lot of wetland areas, areas that are filled with temporary water, agricultural wetlands, things that LiDAR might pick up as water, but it's just water being moved between cranberry bogs or a reservoir for one of the agricultural products. But what this tool or workflow was designed for us to look at our current Huck 14s and then produce, the workflow and an idea on where we needed to look at our boundaries and modify them. So that lower left circle, you might see areas that aren't, you have output in the different colors, and the solid line is the existing Huck 14 layer. So we did that first here, but we wanted to see how this process would flush out in the tidal areas, and just a lot more problems with trying to get this to produce a good output when you're dealing in tidal areas. So when we get this data in, kind of what I'm doing with it is, since we have a pretty detailed streams layer and water body layer, I'm using it to supplement and help me correct the NHD flow lines or streams that we have mapped. So just pretty much my process is to take the raw DEM. So in this case, it was a 2-foot DEM. I fill it, and then I create a minus grid so I could find all of these areas that are dammed up. You can see there's a road here and some kind of dike or berm holding in this water or pond. And another unique thing I feel, I know a lot of NHD folks might be cringing, but our NHD flow lines from the very beginning, we mapped every location that the stream went underneath a road surface as a connector. And if it was over 100 feet at the time, Carl and George wanted us to we wanted to keep the coding in there, and they asked us, well, let's make everything over 100 foot, 125 feet a pipeline. So what I do now is I still maintain all of those. So essentially, if you consider culverts, connectors, and pipelines that are currently in our streams network as something you could burn into your DEM. So that's exactly what I do with it. So I don't have to maintain a separate layer. They are part of the stream network. Create the agreed DEM, I'll fill it, and then create another minus DEM to make sure that those are taken out of the equation as far as drainage lines. So what I don't put in there are the stream artificial paths. So I like to see what comes out of it. So using the 10-foot dam is when I do most of the processing. So I'll do stream link grids, stream grids at different levels. When I do 10 acres, it seems to be pretty close to what NHD is kind of at the level for high resolution. And then I'll do it for usually just use 1,000 level cell accumulation, flow accumulation, and I'll create drainage lines for these two levels. And then I'll start to compare that the streams crossing through the drainage lines are matching or close to matching our streams. So areas that it doesn't match are the ones that I'm going back in and looking to see if I need to hand edit those areas. So in this case here, we had a water body, but both of these, and it may be because of the flattening, that both of these drainage lines went into the flattened area, and you ended up with a double drainage line finding its way to the connector or burned-in area. And I was quite surprised to see that even burning in this connector here across or under the road, that this crossed. So this may be because it's the 10-foot dam and not necessarily the 2-foot dam. So you can see the detail on the left as far as, you know, the red being, you know, primarily an NHD level stream, but the gray ones are the intermittent streams or any headwaters, whatever you want to call them, going up. So those are the ones that I wanted to reference to see if I could connect any additional water bodies to the network. So that's essentially what I did. These were the first two hucks I did because it was the first more detailed collection we had. So anything in red are areas that I extended or added flow lines, either to reach a water body that you could not see on our imagery at the time, a path for the water coming from that water body. So these were two areas that I have ready for completion. I just haven't had the time to get through that process. So red is our current, pretty much what I have now, unless I made a correction. And the blue lines are the existing NHD that has been in the network since 2009. And of course, I always verify the flow directions and edit that as needed. So when I'm doing this, I'm going tile by tile, which is roughly 5,000 foot squares. This is our tiling system for LiDAR collections, our imagery collections, and we use it for all of our statewide tiling. Just a little more close-up of the lines that I've added in. And the green are cells that I've reviewed and finished, and the brown were the ones I'm working. So I kind of stay systematic in my review and QC of the data. So this also produces, you know, or show, you start to see the issues along HUC boundaries, HUC 12, HUC 8 boundaries, and even the HUC 14s. So even though we have LiDAR drainage lines produced from the DEM processing, still digitize it. I may copy and paste those into the stream network, but then in cases I may have to visually edit those to the imagery. Anywhere I see a culvert crossing, I'll add it into the stream network. but I'll code it as a culvert and not a connector. So it may just be a standalone crossing in the data. And that does not go out to the public. I just filter that out when I make this available on our downloads. So I verify all the typical NHD checks of verifying the artificial paths are in water bodies and streams are not, APs are in water bodies, streams are not in the water body, and then I code all the attributes as far as adding a tributary name or Huck8, some of the more basic. None of the other NHD codes get updated at this point. We'll wait until we do a conflation to bring those back in. So this is the latest collection. Been trying to run the ArcHydro tools on the newer DEMs, the hydro flattened DEMs, and without any advanced manipulation of that DEM, you end up with these drainage lines pretty much just following the edges or crisscrossing along the flattened areas. Again, the red line level is the level we would use accumulations for determining the Huck14 boundary. The blue is the level that I would try to make sure it meets an NHD. If there's something in there on the blue that I don't have mapped, then I'm starting to look at it to make sure it's in there. And then the green is the detailed accumulation that I'll reference. You get a little bit more or less depending on the area of the state you're in on that accumulation. And so I don't, unless I need to figure out other processing, utilize the artificial paths going through these flattened water bodies. So this is our NHD as it is today. So I'll use the green lines to either confirm that maybe we had a stream in there that was going in the wrong direction. So I'll look for those, make those edits, and then bring them, change the codes. If it's going in a different direction and it's sourced a tributary off a different name stream, then it gets checked for that. So our artificial paths are all within the water body areas, and some of the LiDAR flattened DEM, derived DEM is actually modifying the path of the artificial flow line, artificial path of the flow line to match the flattened areas that are appearing in the hillshade. So here's just a close-up of our water body layer with the tidal mudflats separated out, and you can see the artificial paths. Again, it's a 10-foot drainage line there. You're seeing in green, so it's more jaggedy than our hand digitized flow line or stream. All of the artificial paths are split at the tidal mudflat boundary because that is actually water. But if you were using just the LiDAR DEM or the break lines to create your water body, you may find a lot of these in your data where it was just low tide when that collection was made. And we spec out our LiDAR collections to be done within a certain time frame of low tide. So this was, again, the 2019 hydro flattened dam, looking at our existing streams. So this was the imagery in 2012 when we first decided we needed this code in there because we didn't want to change the water body boundary on the upper side, but we didn't want to mislead people that this was land area or not part of the water. So we started splitting out from the water that was already in there in the land use to code these areas as tidal mudflats. So this is 2012 imagery, which is when we first added in the NHD coding. And this is the 2015 imagery. So you could see all those tidal mudflats in this particular set of imagery is covered by water. So after we realized we didn't want to keep changing the water body boundary, that we would just keep those low tide areas as mudflats and from the 12, and then if there's any encroachment onto the land, that's the side that for the most part will get edited. And then that's where the artificial path comes out of the water body. So are we doing full hydrography from elevation? No. We're using it to verify and supplement our existing high-res data. So again, our existing NHD data that's on the USGS servers was local data that we conflated into the high-res. And we're preparing, or I've been preparing, to go statewide. Every HUC8 is pretty much done. We just need to get the data prepped for the conflation. All of our data is mapped to 1 foot imagery. And of course, that's not in sync with our LiDAR collections. So those are our base maps for all of the mapping that people do in DEP. So they're always waiting for the next overflight and the next land use update, which always takes another year and a half to produce. So just some observations that I felt that the 10-acre accumulation was best to match some of the NHD delineations I've seen. I go down to the 1,000 cell on 10-foot cells to find those headwaters, and I need to connect any additional water bodies I might want to connect. Getting good, pretty decent streams out of it, at least location-wise. I do smooth. Usually when I take something out of the elevation, out of the drainage line, I'll smooth it and then generalize it again, just so I don't have the vertices that are created from a smoothing process. But you can see in many cases, I'm not going to get good LiDAR drainage lines to match imagery. You'll get a path, you'll get a connection, but in many cases, when you're mapping everything to imagery, it's not going to be an easy path. And then a lot of problems I'm having with processing this QL2 LiDAR. Been running into ArcHydro errors. I'll have processes running for 24, 32 hours before it finishes, and then it bombs. I'm running 10.7.1. I've installed some spatial analyst patches they recommend. It's still bombing even on a HUC12 level clip of the data. And I have a 10.8 machine and I have a 10.5.1 machine. I've tried processing some of that in ArcHydro. So I need to do more investigation on some of these errors that I'm running into. So the challenges for me is getting, not only keeping up the land use, doing the editing and the water bodies and the coding, and mapping the stream flow lines, or what I call the streams layer, is keeping up with the USGS software and the conflation and all of that. I've been trying to get conflation done for the last 2 years and just have not had the time to dive into it. But we're pretty much ready now to start that process. So we're going to be gearing up, moving our software onto a 10.7.1 box, and then utilizing the new schema and starting a new conflation process. And again, just it's been difficult with all the other work to fulfill NHD stewardship and WBD stewardship. I'm the third or fourth person that was the WBD steward, and we just can't seem to find anybody in our group or outside of our group to take that lead. So we have some opportunity with our water resources group, but for the most part, it's still by default put on our bureau. So that's it. That's the end of my slides.
That's
Any
all, huh?
questions? I'll stop sharing, I guess, at this point.
You might keep it up in case we need to go back to another slide.
Okay.
Yeah. I'll let
Yeah.
Emily
Oh.
cull through the slides or through the chat. I have a quick question just to start us off. Now that you are the WBD steward as well, have you used the LiDAR to update the WBD boundaries?
No, we have not. What I have done with our HUC 14s, which our geological survey group, water science group, are the stewards of our HUC 14s, and they were the ones that we worked through that sub-basin workflow process because they were going to be the ones to update it. They had since lost the person that they designated as that steward. So what I did was I ended up utilizing or incorporating our 14s and integrating them so that they matched our WBD HU12 level, which we were partners in updating the HUC 12 boundaries with EPA, probably a good 8 or 10 years ago now. Anything further than that, like I said, I edited our HUC 14s to match the boundaries of the NHD HUC 12s, but I can't get anyone to approve it and put it out there. And then, so what I end up getting now are a lot of these markups from the USGS markup web app. And since I don't have editing rights at this point in time to do that, we just haven't made any effort to do that. So.
All right. Looking at the chat, there are a couple questions here. So Jim from Wisconsin asks, regarding the archhydro bomb, have you tried turning the DEM elevation into centimeters and then turn it into a 16-bit integer? He thinks it might make the math a little bit easier.
No, I have not. I'll have to work with, that's a good recommendation. Have you, if that's a workaround, a known workaround for making that happen, my coworker, John Tarowski, does that DEM creation from the LiDAR. So that's something we'll look into.
Yeah, cool. And then Alan Ray asks, do you do much linear referencing, i.e. linking data to the NHD using reach codes and measures?
I did early on. We were trying to get some of our water monitoring groups to, get into linking it. I had all of our dams linked through the reach codes so that with the tracing, you could relate to our dam locations. We have about 200 more dams that are monitored by our dam safety group than what's in NHD because of the size. So, we did produce a layer. That coding is in there. We just don't keep that in on our servers at this point. But it was done at one point. And we also have some web applications that are linking the data and tracing to water intakes.
All right. Are there any other questions? Feel free to either put them in the chat or at this point, just unmute and go ahead and ask.
Craig, this is Phil. I have a question about the accumulations that you're using. It
Yeah.
sounded like the 10 acre was something that was analogous to the existing NHD hydro, but that you do map it to sound like a 2.3 acre catchment. Do you have any interest, or would you prefer if that data was also conflated into the NHD?
I don't, it's a lot of headwaters. It's a lot of intermittent streams. There might be a lot more roads, crossings that it's trying to cross that may not be in the right areas. I would say no to that question, only because because I'm mapping up to imagery. I would think that the objective of just connecting as many of those water bodies through a visible and somewhat invisible flow path is really the level I think we'd want to stick to.
Okay, makes sense. You also mentioned when you do conflate that you're having to drop a lot of the names because they're not in the GNIS.
Right.
Did you look at, or have you looked to add those names to GNIS so that they will conflate?
So I get the GNIS database, and anything that's in that is accounted for. The rest of the names really are a throwback to the DLGs that used to put names on things like unnamed tributaries and with numbers and codes. So it's in there only as a matter for spatial referencing for people, knowing, if they're dropping or doing a monitoring point somewhere along a stream that they're, or a bridge that they're on a tributary of possibly a named stream. But yeah, I don't want to be adding things into the GNIS board unless it goes through the proper channels of adding in, in the application to add a name.
Great. We do have a couple more questions in the chat. Which user applications are the biggest drivers for your local res hydrography?
What are their biggest? I'm sorry, what was that?
Yeah, which user applications are the biggest drivers for your local res hydrography?
Gosh, I know our land use and the water bodies and streams are all pulled, by the counties. DEP, there's so many organizations in our group that, do the water monitoring. They'll reference it to that. Yeah, I don't know if there's just one, actually.
Yeah. And then are there any special treatment of wetlands? Like, are they water bodies? Do they connect as headwaters?
Yeah, the wetlands, because of our land use type coding, we have a variety of different wetland codes. The wetland areas that might be hydro flattened in the LIDAR dam, again, might be a temporary water holding reservoir for a cranberry operation or a blueberry. So we'll code those as agricultural wetland. So they're not getting captured into our water bodies. And there's just, if you were to map water in these wetland areas that are water one collection and water, completely dry in another imagery, you'd be spending all your time mapping those boundaries. So they go into our wetland categories. Sometimes those water bodies will be a reservoir code if we do map some of them, but for the most part, they're not brought into the water body. layer.
All right, and then I think one more question I can see so far. The difference between 40,000 GNIS records and 269,000 total records is pretty striking. So please elaborate on the types of records in the local database.
I'm looking for the questions. I'm sorry, could you repeat that?
Yeah, it's right now it's the third one up in the chat from Eric. The difference between 40,000 GNIS records and, yeah, have you found it?
Yeah.
Okay.
The difference between the 40,000 records, is that the water body?
Eric, go ahead and unmute if you have any.
Yeah, I figured
elaboration.
Eric would have a question for me.
Oh, yeah, thanks. Yeah, well, you know, so you got 40,000 records, 39,774 records in the GNIS and 268,000 something. It's just amazing difference. What are they in general?
These are water bodies?
All water bodies? I don't know.
Yeah,
Yeah,
these
not
are
DNS.
all the water bodies, streams. So NHD area, NHD water bodies are all in one water body feature class that we push out internally. These are the flow lines. Okay, so these are the artificial paths, the streams, etc., connectors. Every segment of the flow line is in this stream network. So maybe that's what you're referencing in your question.
Well, one last request from me is if you have not already, please put your name and organization or state into the chat. Hopefully we're able to catch most people, but if you haven't done that already, go ahead and please do that. And if, of course, if there's any other questions, please pop them in the chat or feel free to ask.
So we have our standard end of the presentation questions. And I think a lot of these have been addressed, but I'm going to go through many. What are your primary motivations for creating this, and what issues have made it clear to you that all this work that you've done has really been needed?
Well, it really goes back to the 2002 timeframe when the only streams we had on our servers were the DLG lines, and our C1 water body water monitoring group was starting to implement laws that buffered C1 designated waters by 300 feet. And when we started to look at, the delineation of this line work through water bodies, and they were going through neighborhoods, they were going through houses. So we made that effort to delineate in 2002, which the imagery wasn't 1 foot at that time. So delineate, basically the project was to delineate all streams that were visible on imagery that were either in the C1 water body or C1 layer that might have been fixed, or in the DLGs or on the topo quads. So we wanted to make sure that we got a good stream layer out of that project in 2002. And of course, we had the water bodies out of the land use update. So that brought us to the point where we were approached by the RALA group and Roger probably spearheaded it, to get all of that data into the NHD. So I coordinated all the conflation work through a vendor to make that happen. And that was finally completed in 2009. Since that time, I've been involved in the land use updates, and I've just looked for, ways to, it's hard in the beginning, but try to make it easier for the next conflation, because in a year and a half from now, when our next update is complete, you know, technically we should do another complete conflation project. So hopefully all the attributes are in there, and if we have to do another one in 2 years or start it, it'll make it easier. But as far as motivation, I don't know. I don't know what keeps me going. I'm getting tired of editing streams for 6 years, you know, to get a project. But yeah, I don't know. We're the stewards of it, so I do it.
So what has surprised or challenged you the most in this whole thing?
I thought it was going to be easier, you know, to get some good data out of these newer LiDAR collections. And until I figure out what all these error issues, you know, why I'm getting this, so that surprised me.
So
I'd
just
really like to,
processing the QL2 data efficiently
Yeah.
has been the challenge.
yeah, and I'm not sure if it's the hydro flattening that is an issue, or the just the way it's been created. If ArcHydro is having a problem reading that data, so still got a lot of things to iron out to leverage that. Because at this point, I have not been able to successfully create an agreed-dem with those culverts on any of the newer collections.
That answer set this up for our last one. So what additional resources do you think should be developed by you or others to support this effort? So here's your what's your wish list?
Well, if maybe if the GS is putting out, you know, these elevation layers, that they could work out the process for you know, getting the culverts in there, so that the tools, you know, I've worked with Dan Dojic quite a bit over the years, and you know, we're bought into using ArcHydro, but if there's other tools available that we could utilize to make this happen, then we'd like some, you know, just figure out who's been successful with it, some other guidance.
Well, great.
It may be out there, I just
Yeah.
not
Right.
aware of it.
Well, Craig, thank you so much. It was an excellent presentation, and thank you too, Andy. The reminder of our next webinar is Wednesday, May 19th, 2021. Invite you all to come back. And if you need anything in the meantime, there's Linda's contact information and mine. This presentation will be posted to the NSGIC Learning Link. And thank you everyone for attending today, and have a great rest of your afternoon.
Thank you, Phil.